The Sigmoid unit training, you can use the same data as the one that we did with the TLN, the threshold logic neuron. And this one will be target RT. And you have to find the summation of all here. 1, 0, 1, 1, 1, 0, 1, 1, and 1. The target is 0, 0, 0, and 1. And guys, how about the output? The output is you have to find the summation first. Sum of W times X. Okay, but you have to initialize W first. So it can be like a small random number that can vary from I'll go to random number divided by subtracted by 1 and divided by 10. So this one is small constant, starting small constant. So you can copy and pass the values only. So we can fix the values of weight here. So the summation will be W0 x0 plus W1 x1 plus W2 x2. Okay, and you have to pass these values to sigmoid function. So the output will be 1 divided by 1 plus e power minus this one, right? This is a sigmoid function. So this is the result. And how to train it? Quite simple. Delta W0, delta W1, and delta W2. And the training, the learning rate is 0.1 for the learning rate. So guys, can you remember? This one is learning rate times target minus output times output times 1 minus output times x. But you have to fix all columns here, so it will become d minus I minus I minus I here. Okay, so let's check for, can you see? Because x1, x2 is still 0. So delta W1 and delta W2 is 0 in this case. And then you can use W is W plus delta W. So it will be this one. And this one is, you can get sum of W times X, and this is the output. This one is delta W. So again, you can copy all of them. So the result is like this, and you have to copy the training data here and copy this line to 4 iterations here. Okay. Now you have to compare these columns. This one is the one that you want, right? So it should be this. And this one is the output. So it can be yellow. Okay. So you have to make like to make output closer to the target. So it is like this. So you have to do it many iterations. Okay, just wait. So I would like to copy all them. Okay, so this is just not greater than 200 iterations, so it's fine. Okay, I will copy more rows to make it faster. Start from this row to the end of this, so it will be like this. So you have to wait for all spreadsheet to be calculated first. Okay, so at this time you can see that for the first three rows, here, it is like the output from the first three rows that is negative becomes lower, right? And the last one become higher. So just wait and we can check the result. Okay, so you can repeatedly do it until you can get the satisfied one. Can you see now? It is like become zero, almost zero here, and it higher. This one, the last one, is higher to be 1. Okay, I will add 2,000 more rows, and I will copy all rows here, and you will see the result. A moment. Okay, I'll start from this row number 6 to row number 1000, around that, 1200. Copy and paste. Okay, now let's check the result at the end of this spreadsheet. Can you see? It becomes 0.24, 0.24, and this one is 0.7. You can pass it again for another 1000 rows. Yes. So finally you can get the weight that can correctly classify these example. So once you finish watching this video, you can come back and check this spreadsheet. I will make it like 10,000 more rows for you to check, that you can check the result. In the next video clip, I will show you how can we write the Python using Python programming to train the perceptron. See you in the next video clip.